Perfect. Um, I need to fix that speaker. Welcome to United Astronomy Council, New Jersey. We are back on site on this rather cloudy, windy day in Hope, New Jersey, in Jenny Jump State Forest. I want to welcome all of you who are not only joining us. Behave. All right. Sometimes all right, let's try this. Maybe if I. All right. Anyhow, welcome all of you who have joined us here, and not only online, because that is right, we do live stream these presentations on YouTube and Twitch. So if you're ever wondering what to do on Saturday nights at 8 o'clock, and you happen to have a internet connected device, you can always join us there and join in and say hi on chat. So, well, I think there's a couple people just finishing parking up there, just to give them a little bit to get down, find a place to set up a chair and get settled. First off, do check us out on our website, uacnj.org. It's where you're going to find a list of all our upcoming talks we've had in the past, and information on our member clubs, because we are actually an astronomy organization made up of our member clubs. And the best way to get into astronomy is to actually get involved with your local club. So we do try and promote our local clubs there. We also try and promote Jenny Jump State Forest. Great place. They have camping, hiking. We have a number of campers out here, I've heard. So do check them out.
Hiking earlier.
All right. And you can also check us out on our social media, our Facebook, our Instagram. We have a Discord server. All great places. If you have questions, you want to know more about astronomy, or just show off your great pictures you took, or ask questions about your astronomy rig, your telescope.
Ask how to take great pictures.
All great sources. So it looks like perhaps we're done wandering down. So safety briefing for those of you who are here. If you need to use the restroom, that is the porta potty in the back. It is blue. In the dark, it is illuminated by red for ease of seeing. In addition, we have a museum and gift shop area. Today I actually have a friend who's helping me attend to that, so you don't have to wait until after the presentation. She is in there and she can help you. After the presentation, assuming the sky smiles upon us and grants us a lack of clouds that we currently do not have, we will have stargazing. In each of those sheds you saw when you were coming in, it houses its own telescope. Any shed with its roof rolled off has an observer there monitoring the telescope, and would be more than happy to show you what's up with that telescope and what they can currently see, which is nothing since clouds. Visual telescopes, not that great during cloud cover. When we do go to leave here, for people who drove, do use your headlights. That's right, even though they are very bright and blinding, we want you to use them because we do not want to get run over, and we do not want to see people get run over. This is not Frogger. It is not 10 points. Let's avoid that paperwork. No one needs those medical bills. That being said, if we have any flashlights, do keep them pointed towards the ground. It is a state park. It does, in fact, get dark at night, especially when there's cloud cover and a lack of moon. So do keep those flashlights pointed down. We don't need any impromptu flashlight raves. With that, you're not actually here to hear me ramble on for forever. You're here to hear Dan here ramble on forever. There's a reason.
Accurate.
There's a reason why we say the question and answer session is at the end. He is one of them, because if we get him off track, that's it. We will be here all night.
It's true. It's true.
So question and answer session will be at the end. But Dan here is here to give us a presentation about the Fermi paradox. Daniel Kirby has a bachelor's degree in physics with a minor in history and a master's degree in computer science. He has been an amateur astronomer since childhood and a member of the board of the Amateur Astronomers Association of New York and on the board of the United Astronomy Clubs of New Jersey here. He's also the site coordinator for AAA's activities here, and AAA being the Amateur Astronomers Association of New York, not the other one.
We're not the other one.
Not the roadside service one. Although AAA, that organization, great thing to have when you're driving around here. He has spent many a lonely night, which is false because he normally brings friends or invites other astrophotographers up here with him at night at wandering between the stars. And while astronomy is by far Daniel's most passionate hobby, he also enjoys reading, cycling, camping, and riding self-balancing personal electric vehicles. For his day job, Daniel's a software engineer and will shamelessly plug his astrophotography work later.
Yeah, my Instagram. All right, so let's get down to business. So the title of this talk is Let's Solve the Fermi Paradox. So we're going to be talking about the topic of extraterrestrial life. So before we start, I just want to take a little poll. Raise your hand if you believe extraterrestrial life exists in our universe. Okay, cool. Now raise your hand if you think that there are extraterrestrial civilizations in our galaxy. So that would be like 100,000 light year radius. Okay. What about if there are extraterrestrials within 100 light years? So that would be like a little bit less than this circle surrounding our sun in this picture. Okay. What about in our own solar system? What about on Earth right now? All right, keep your hand up if you think there are extraterrestrials in this observatory with us. Okay, so I'll give you a little spoiler warning. It's hard to talk about this topic without talking about science fiction, and I do my best to not give too many spoilers for sci-fi novels, but a lot of the really interesting ideas around extraterrestrial life either come from or are best illustrated in science fiction. So there's going to be a little bit of a spoiler. So just a little bit about what we're going to do tonight. So this talk is split up into 4 parts. So we're going to start by coming to grips with what the Fermi paradox is. We're going to talk about where, like, the history of this discourse within astronomy. We're going to go through a set of solutions. We're going to go through 4 solutions to the Fermi paradox that suggest that we are alone in the universe and there are no extraterrestrials. We're going to go through 4 solutions that suggest we are not alone. And then we're going to do a March Madness bracket, and you're all going to choose which you think is the most likely solution out of the ones I've proposed. That's not one of them. Michigan's not a solution to the Fermi paradox. So first of all, what is the Fermi paradox? So the Fermi paradox was articulated by Enrico Fermi in 1950. So Enrico Fermi, you probably heard of. He's an Italian-American physicist. He worked on the atomic bomb, and at the time, he was working at Los Alamos, and there was this newspaper cartoon that, so apparently at this time, all the trash cans in New York City were going missing. This was before Eric Adams brought them back. And so there was this New Yorker cartoon that showed these aliens landing and bringing the trash cans back because nobody knew where they were going. And so Fermi and his colleagues were talking about this comic, and they were talking about the prospect of interstellar travel. And Fermi just says, if that's possible, if we could go to another solar system, where is everybody? And so this is kind of, just a comment that he made at lunch, but that has been kind of expanded into this notion that goes sort of like this. Basically, the idea is that our universe is very large. Our universe is much older than we are. If interstellar travel is possible, then you could colonize the entire galaxy in just a few million years, which is small in cosmic terms. And yet we don't see any evidence of extraterrestrial contact here on Earth. So a related idea I'm going to explain because I think it'll help motivate reasoning is the Dyson dilemma. So this is about 10 years later. In 1960, Freeman Dyson observed the fact that our civilization has historically demanded an increasing quantity of energy. Basically, like when you see energy consumption drop, that's usually a bad sign. Like something bad happened, like during COVID when nobody was driving, so we don't need as much gas because we're not going to work. Energy consumption goes down. So if you extrapolate that, it seems that basically civilization will need all of the energy that the sun puts out. So why don't we see stars winking out of existence as their inhabitants basically box them up into what we call Dyson spheres? So it's this idea of like, oh, you're going to surround the entire star with solar panels. We see our stars disappearing because of light pollution. That has nothing to do with aliens, and also the clouds up here. And then the third idea I want to touch on is what's called the Great Silence. So we've talked about this idea like that Fermi's talking about, where he's saying, why are the aliens not here? Dyson's talking about the idea of, well, we should be able to see evidence of other civilizations based on how they change the environment in space. And the Great Silence is just the observation, which took decades longer to produce, which is that there are no signs of extraterrestrial communication. We never see any like repeating sort of anomalous signals from space saying, hey, hello, we're here, we want to make contact, like in that movie Contact. Now, there's an exception to this. This is the WOW signal. This is the actual signal on the paper. So in 1977, there was this radio telescope at Ohio State University that was basically designed to map the hydrogen sky. And the way this radio telescope works is it basically just points up. You could aim it north and south, but east and west, it's just pointing up. So it's designed to basically sweep the sky as the Earth rotates, and it was used to map the hydrogen in the sky. Like when that project was finished, Frank Drake, who was an astrophysicist who was really interested in this idea of searching for extraterrestrial intelligence, suggested the idea of using this telescope for this mission, because the idea is like, well, the frequency that hydrogen vibrates at, 1420 megahertz, is actually relatively quiet, and it's also something that any civilization would know about. We know that hydrogen exists, and we know how it makes state transits, and we know it emits on this frequency. So they started this project of just recording the signal from the telescope, and they gave a grad student the printouts, and they had him like just scanning through looking for anything strong. And this scale is actually like 1 to 10, and then it goes to letters. So 6EQ UJ5. It's a really strong signal. He circled it and he wrote wow. So we call it the wow signal. Now, there's been other candidates since the wow signal. None of them have ever repeated. Up until recently, if you asked me, I would have said that the best explanation of the wow signal was extraterrestrial intelligence. Not that, I think that's what it is, but just that it was the best explanation. There recently was a paper that came out that was a fairly compelling natural explanation of what it was. It was probably like a gamma ray burst, scintillated like a cloud of hydrogen. It just happened, like we just got lucky that we saw this crazy signal on the hydrogen line that you usually don't see, and that's why it hasn't happened since then. So that one more idea I want to introduce is that of the Kardashev scale, which will sort of tie all these together. So basically, I talked about how our energy consumption is expanding. So Nikolai Kardashev was a Soviet astronomer who basically proposed that this 3-tier scale of like a type 1 civilization would be commanding 100% of the energy output of its planet. So where are we? We're like 0.7-ish. Like we're getting close. Type 2 would be that Dyson sphere level. That's when you've encapsulated your sun and you're taking all the energy the sun is putting out. And type 3 is when you get all the energy output of your galaxy. So you colonize every star and you put them all into Dyson spheres, right? So that kind of, to sum it up, basically what I've introduced here is that we are alone in 3 ways. We don't appear to be the province of some galactic empire like in Dune. So that would suggest that, we're not there isn't a type 3 civilization that is in our galaxy, right? we haven't found any like alien artifacts or like ancient evidence of ancient aliens exploring our solar system or our planet, like the monolith from 2001: Space Odyssey, which would be likely like a Type 2. And we haven't seen any radio signals from other civilizations like in the movie Contact, which would be possible with a Type 1, could be kind of like almost anywhere on the scale. But like in actual fact, with our current technology, with our current radio telescopes, we could communicate with another Type like 1 civilization basically anywhere in the galaxy. Like as long as we have line of sight and they know we're here, we know they're there, we could have a two-way conversation. So just some rules of thumb I would like you to consider. One, these two sort of contradict one another, or they are somewhat conflicting: the Copernican principle and the anthropic principle. So the Copernican principle was, as you might imagine, articulated by Copernicus. And basically the idea of the Copernican principle is that you want to assume that your place in the universe is in no particular way special. You represent a random sample. So a sort of concrete way to think about this would be like if you take a bus every day to work and it comes every 10 minutes and you don't want to check your watch, but somebody comes up next to you and says, "Hey, what time is the bus coming?" You can probably be safe to just say, "Yeah, 5 minutes." Because like on average, right, like if you just randomly show up at the bus stop, on average, you're 5 minutes away from the next bus. Now, the anthropic principle is basically just the observation that the range of possible observations is restricted by the constraint that we have to exist. So, like if there anything that dictates, whether we can exist or not, it restricts that sample space. Like we are not a random sample of every time and space in the history of the universe. We are a random sample of the ones where we can exist. Like we don't live on Mars for a reason. Mars is not habitable. At least not yet. And then one more kind of interesting one to think about is exclusivity. So basically the idea here is that whatever explanation we come up with, it must have the property that it is exclusive to all civilizations. So for instance, we would say that civilizations that develop radio communication have to have mathematics. You can't develop radio without mathematics. But civilizations that have the technology to contact us and civilizations that think we're boring and don't want to talk to us are like a Venn diagram that intersects. Because, well, this may come as a surprise to you, but there's people who are interested in almost anything that you think is boring. Like the people think Ohio is boring. Ohio's tourism revenue is like billions of dollars a year. So it seems likely that if there's aliens out there, some of them would be interested to talk to us. So okay, so what if we are alone? What reasons might we be alone? So the great filter is something that often comes up when you look into the Fermi paradox. It was articulated in 1996 by Robin Hanson, who is an economist. And basically his observation was that there was a series of sort of difficult milestones that had to be passed to get from the first like living things on Earth to our globe-spanning industrial civilization. And it's possible that one of these milestones was basically nigh impassable, that like 99.9999% of life-bearing worlds will not pass this filter. So some ideas about things that could be the great filter. Maybe the emergence of life on our planet. Maybe the transition from prokaryotes to eukaryotes. So prokaryotes are like simple single-celled organisms. Eukaryotes have like internal organelles that like the mitochondria, which as we all know is the powerhouse of the cell. What we think happened is that one prokaryote ate another prokaryote, and like the inside prokaryote was like, "Hey man, I don't want to get digested. Maybe I could help like run stuff inside here." Transition to multicellular life. There's some recent results that suggested this is probably not it, because there was a laboratory experiment that kind of recreated some of this. And maybe the emergence of intelligence. Maybe intelligence isn't actually that great of an adaptation. It kind of seems like we're using it to destroy our own planet. And that leads me to great filters that might exist in our future, right? Like nuclear war, climate change, artificial intelligence. That one gets more interesting every time I say it. Pandemics. Now, you might be thinking, like, wait a minute. Pandemics can happen to any civilization. Industrial civilization doesn't have to exist for there to be a pandemic. That is not true. An epidemic could happen at any point in human history, but a pandemic, as in like the entire world is experiencing an epidemic, requires international travel. It requires at least maritime travel, if not air travel. And there could be technological hazards or future hazards that we don't even know about, right? Like if we were making this list 100 years ago, I don't think we would have thought to put down artificial intelligence. So for all we know, there's some technology in the near future that could be a great filter technology. Now, how does this solve the paradox? What does it actually mean for there to be a great filter? Well, what it means is that if the great filter is behind us, we've already passed it, then we're sort of the firstborn civilization. There's nobody else out there, and the stars are ours. We can keep them and use them however we wish. If it's ahead of us, then there's probably a lot of civilizations that are similar in technology to our own, but all of us are doomed to fall to the great filter sometime in the next few million to billion years. Another explanation, articulated by Peter Ward in his 2000 book Rare Earth, is the rare earth hypothesis. This is the idea that the earth is itself, special in ways that are really uncommon in the cosmos or in the universe, right? So our planet orbits a stable, long-lived single star in that star's habitable zones. So stars by themselves are actually quite uncommon. The most common star, whoa, that's all wind. So the most common yellow dwarfs in our galaxy are binary stars, like our nearest neighbor, Alpha Centauri, which is actually a 3-star system. It has 2 yellow dwarf stars and a red dwarf that orbits them. Red dwarfs are more common than yellow dwarfs, and they are longer lived. But the thing with red dwarfs is also that their habitable zone is so small, because they are so small, that their planets probably get cooked with radiation. Our orbit around the galaxy is in what we call the galactic habitable zone. So this is kind of an extension of that habitable zone idea of like, oh, you need to be far enough from the sun that liquid water can exist, but not so far that it's ice. The galactic habitable zone is sort of this idea of like, well, if we were closer to the galactic core, then there would be more frequent interactions with neighboring stars, which could be like a threat to us that could pull planets out of orbit. They could, release radiation that could be hazardous. But if we were farther away from the galactic core, because we're kind of in the middle of the arm, right? If we were closer to the rim, then we would have fewer heavy elements, because those stars are younger and they don't have as much like of the elements that make up our civilization, like iron and calcium, potassium, and whatnot. Another thing about our planet is that we have an unusually large moon. Our moon is actually so big that some people have historically suggested that we are a double planet. Our moon is bigger proportionally to its planet than any other moon in the solar system, I believe, with the exception of Charon, which is Pluto's moon, which Pluto actually is a double planet. And by the way, I believe Pluto's a planet. So this book came out in 2000. Exoplanet astronomy really started taking off in the mid-90s and really kicked into high gear in the late aughts and the 2010s. And since that's happened, we've basically observed that other solar systems really don't look like ours. So our solar system has 4 terrestrial worlds: Mercury, Venus, Earth, and Mars. And then it has an asteroid belt, and then it has 4 gas giants, or 2 gas giants and 2 ice giants: Jupiter, Saturn, Uranus, and Neptune. We sort of assumed, like up until the 2010s, that that's basically what solar systems look like. That you would have like an asteroid belt in the middle, rocky planets near the sun, gas giants way out in the boonies. We now know that actually most solar systems are kind of all one or all the other. Now, that lends credence to this argument, but one point I'll make here is that an implicit assumption is that we need an Earth-like planet to have a civilization. So, like, some of the most interesting, like, places to look for alien life don't look anything like Earth, right? Like, we're curious about the ocean moons of the outer solar system, where you have like a liquid water ocean with an ice ball around it, like Jupiter's moons Europa, Ganymede, or Titan. So it's possible that, maybe like okay, so the conditions for life as we know it might be pretty rare, but there could be other scenarios where life could exist. So another idea is that maybe we're just early. So I already sort of alluded to this idea that like we're implicitly making an assumption in the Fermi paradox statement that civilization is sort of equally likely to appear at any time in the history of the universe. But we know that this is not true because we know that our civilization relies on heavy elements that didn't exist in the early universe. So when the Big Bang happened, the entire universe was just hydrogen and helium. And you can't make a rocket out of hydrogen and helium. You can't make a radio dish. You can't make a smartphone. Like, all the things that we think of as civilization require stuff way up on this table. And you see, like, I'm not sure if the live or the in-person audience can see this, but what this table is showing is where the elements come from. So hydrogen and helium come from the Big Bang. A bunch of them come from low-mass stars when they go nova. Some of them come from high-mass stars when they go nova. That's the yellow. The green is the low-mass ones. The pink is cosmic ray fission, which appears to be beryllium and boron. The purple is merging neutron stars, and the white is exploding white dwarf stars. So you see how a lot of elements that we like consider to be really vital to sustaining our technology actually don't even come from Earth. In fact, none of them come from Earth. They all come from the stars. But some of them come from stars, not the sun, like astronomical events that happened billions of years before the Earth even existed. So Mario Livio is an astronomer who's written on this topic, and he basically believes that there's no civilization in the universe that is more than 3 billion years ahead of us, and he bases that on the production of carbon in stars. Since, our bodies are made of carbon, we're pretty sure that life requires carbon. I know some people are going to ask me about silicon-based life, and I will give my explanation of why I don't think there is silicon-based life. But I will also point out that stellar carbon production has actually not yet peaked. So if you're going off of that, we are definitely early. It's also possible that we're early because later on, the galaxy is fully colonized, right? So, but Robin Hansen actually wrote a follow-up to his work on the Great Filter called the Grabby Aliens model, where he basically makes this argument that actually in the future everything becomes a galactic empire, and hopefully we get to be one of them, like in Dune. Anyway, this is the part where I'm supposed to plug my Instagram. I took this picture of the Dumbbell Nebula, which is an example of the kind of astronomical event that creates heavier elements. My Instagram profile is @TheIntergalacticWanderer. So maybe life is common in the universe, but intelligent life and industrial civilization are not common, right? So as I already mentioned, it seems like alien oceans are super common. Basically, all the outer planet moons seem like they have them. But maybe it's possible that if you have like a bunch of fish swimming around in like a freshwater or saltwater ocean under like a moon, that you just don't invent civilization because you can't make fire. And this is actually, by the way, the plot of the movie 2010. So we also can observe among other like species on Earth that many of them appear to be basically as intelligent as we are, including other apes, dolphins, whales, but unlike us, they don't have complex language. And we know that there are at least 20 other hominid species, like human-like species like Neanderthals, that existed on Earth, and yet only we created a civilization. And as I noted in the Great Filter Hypothesis section, industrial civilization is actually creating a bunch of dire threats to us, like climate change. And also, it's worth noting the dinosaurs ruled the Earth for millions of years. They never invented a steam engine, the internet, space travel, or Netflix. Okay, so those are all the bummer solutions. Those are all the reasons that we should be sad. Now we're gonna get on to the cool ones where there's aliens. Um, so is it possible that we just don't know what we're doing and we don't know how to look, where to look? So you may have heard of Percival Lowell. He was a really famous astronomer. He was a Boston Brahmin, which is a term for sort of the wealthy elite of New England. And he built an observatory in Arizona, which is still open today. You can go visit it. And on any clear night, unlike this one, you can go see some beautiful bits of the cosmos through his telescopes. So Percival Lowell was really obsessed with Mars, and he looked at Mars through his telescope night after night, and he made these detailed maps of what he believed were artificial canals on the surface of Mars that the indigenous civilization was using to move water from the poles to their equatorial cities because the planet was dying. It's a desert planet. It's worth noting that Percival Lowell was writing about this at a time when canals were cutting edge technology, like the Erie Canal, the Panama Canal. These were being built at this time. So it's possible that, some of his biases may have crept in here. Maybe if we were looking for aliens today, we should be looking for, them doing TikTok dances. Now, it's also worth noting, by the way, that Mars does not have a civilization on it that was building canals. So what was Percival seeing? Like, what was he drawing? Because he did this night after night, year after year, and he always drew the same maps. Well, so Carl Sagan, when the Viking lander landed on Mars and brought back really detailed photographs of the surface of the planet, he actually tried to replicate the experiment with the notion of like, well, what if he's just doing like a connect the dots, right? Like, what if he is seeing real surface features but drawing lines between them that aren't actually there? And you can kind of like, it kind of looks like that in these two photos, right? Like, it kind of it's like that looks like it's a real thing, right? Like, that looks like it's probably that, and like this might be that, right? Well, no, it's not. It's not a game of connect the dots. Percival Lowell was most likely drawing the veins in his eye that were backlit by the light from Mars, and that's how he got this idea that there were these canals there. He was not the only person to see them, by the way. The person who was the first to talk about there being canals on Mars was an Italian astronomer named Giovanni Schiaparelli, and he called them canali, which in Italian means channel. It does not necessarily mean an artificial structure, but when translated into English as canals, people got excited about the idea that this was something artificial. So it's possible that there are extraterrestrial civilizations out there, maybe even trying to get our attention. But even in the radio spectrum, how would we know what frequency we should be listening on? It's worth noting that we actually don't spend a lot of money on doing SETI research. It's actually one of the hardest areas of astronomy to get funding to do. And we have not spent a lot of time looking at or nearly as much of the sky than I think the average person thinks. We have a radio telescope here at Jenny Jump that was once used for SETI research. It's actually sitting idle behind the house. So if anybody wants to look for aliens, please let us know, because we have the equipment. Now, even the WOW signal hit in 1977, the total observing time that was spent trying to reacquire the signal using the Big Ear telescope was only 100 hours. Part of that is the constraints dictated by the fact that it was based, like, it literally relied on the rotation of the Earth to aim it. Part of that is also just a lack of funding. So this is a visual representation from Sky and Telescope magazine that kind of is meant to show you how much of the sky, like, we've actually looked for aliens. So on the x-axis is the frequency of the light or electromagnetic rays. On the, I guess, the bottom axis the y-axis is the fraction of the sky that was searched. So you'll notice that there's usually like two versions of the same survey, because it's like there's a northern hemisphere one and a southern hemisphere one. That's what happened with, I think, Meta 1 and Meta 2. And then the z-axis is the relative depth into space. So worth noting here, they have to use the phrase relative because depending on what kind of signal you're looking for, the distance you're going to detect it from is different, right? Like if we're looking for just, something that is accidentally being leaked toward us, like the weather radar, which we are blasting into space constantly, that, is going to be at a closer distance before we're not able to see it anymore, compared with like there's a beacon that's literally saying, hey, hello everybody, we're here. So now on to what I think might be my favorite solution. It's definitely my favorite book that I reference in this talk, is the dark forest hypothesis. So the dark forest hypothesis was articulated by David Brin in 1983, but the spooky name didn't come out until the 2008 novel The Dark Forest by Cixin Liu, which I don't know if it was called that in Chinese. So it might have been a few years later when it was translated to English that the name certainly became common in the West, after it was translated. But basically, so this is the dark forest hypothesis as articulated by the book. Suppose a vast number of civilizations are distributed throughout the cosmos. Suppose that survival is the primary need of civilization. Suppose that civilizations continuously expand over time, but the total matter in the universe, and therefore the resources in the universe, remains constant. So the idea you're supposed to take from this is that all extraterrestrial civilizations would be hostile. And worth noting, in an interstellar war, you would probably want to win on the first shot, because there's this problem, right, where like, suppose we decided to go to war with Alpha Centauri. They're 4 light years away. And even at, 1% of the speed of light, it's going to take us 400 years to get there. So you don't really want to have a scenario where your invasion fleet arrives, sits down on the planet, and you find out all your weapons are obsolete. So actually, probably the most effective strategy for an interstellar war would be something like this, which in this illustration, this is what would happen if like a small moon hit the Earth at like a relativistic speed. So like a relativistic impactor is this idea of like, I'm launching a missile that's going 99% the speed of light. So at 99% the speed of light, if once you see it, it's 99% of the way here. And like when you see it launch, it's 99% of the way here. Another option would be like a particle beam weapon, which could even get closer to the speed of light. My favorite like cool sci-fi idea in this area is the idea of using information warfare, right? Like if you've seen Contact, there's this idea where like the aliens send us blueprints to build a machine, and the machine is like a wormhole generator that we can use to go and like visit them. But like, what if they send us blueprints for a machine and the machine's actually just a bomb that destroys our planet? Like that would be really, I mean, be a cool idea for a sci-fi novel. I want that to happen. But so that's the dark forest hypothesis. What is the problem with the dark forest hypothesis? Probably the biggest problem with it is that there is no way for us to hide. So like, we're not hiding now. There are very clear signals and signs that Earth has a civilization. And even if we tried to hide, like for instance, we would have to turn off our communication systems, our weather radar, our air traffic control, our missile defense systems, all of which emit radiation into space that is easily visible. Even if we turned all that stuff off, that would do nothing to recall the signals we've already sent out. And there are obvious signs of life on Earth that have nothing to do with radio communication, right? Like Earth is bathed in oxygen, which is a gas that is not common in nature, except in sort of special situations where something creates it. Like oxygen oxidizes. The reason that there's no oxygen in the atmosphere of Mars is because Mars is covered in rust, which has trapped all the oxygen on its surface. And I could go on and on about biosignatures, technosignatures, and whatnot, but the point being that if somebody's out there and they could tell we were here, they know we're here. It's also possible that maybe interstellar civilization just doesn't exist. So this is a map of the British Empire. I believe this is from 1901. It might be a little bit later than that, but this is actually their communication system. So this was the height of the British Empire. They controlled about 23% of the world's land mass and a similar percentage of the population. I think it was a little bit less, a little bit more, some in that ballpark. And so, supposing I was the prime minister of England, and you were my viceroy, in India, and I wanted to send you a message to say what my orders are, what's your marching orders for the day. I could tap 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 in Morse code. The signal would go across to, I guess that's probably Grenada, right? And then down to South Africa, up to whatever island that is, maybe Diego Garcia, whatever, in the Indian Ocean, and then up to Ceylon, where it would get to you basically immediately. Now, suppose I'm the Galactic Emperor here on Earth, and you're my viceroy over at Alpha Centauri. So I'm going to send my orders, and the signal's going to take 4 years to get to you, because that's the speed of light. And now I have to wait 4 years after that for your response to find out whether you actually decided you were still part of my empire. So a critique of or another articulation of this, it comes from Kim Stanley Robinson's novel Aurora. He basically articulates it this way: life is a planetary phenomenon, so therefore we'll encounter basically two types of planets: hostile environments, basically where there could be diseases or like things like prions or other biological agents that would be hostile to Earth life, or completely lifeless rocks. And well, okay, so like if we want to colonize a lifeless rock, we've got plenty of them here in our own solar system. We have the moon, we have Mars, we have all of the asteroid belt, we have the moons of the outer planets, and also resources, right? Like, every time you see a sci-fi alien invasion story, they have to come up with some kind of resources that are special that the humans want to get, or that the aliens want to take from us, right? Like, it's usually they want to steal our water. Like, you ever seen Battle Los Angeles? That's what the aliens want, is they want to steal Earth's water. That sounds ridiculous to an astronomer, because water is actually one of the most common elements in the universe, or molecules in the universe. Water is literally made of hydrogen, the most common atom in the universe, the most common element in the universe, and oxygen, which reacts with everything. So, like, you could find water basically anywhere. We know now there's water on Mars. There's water in the moons of the outer planets. Pluto is kind of made of water. So, like, if aliens show up and they want some water, we can just, hey, man, just back up the truck and take Pluto with you. At least then we don't have to debate it anymore. Or like if you've ever seen the Blue Alien movie, Avatar: Way of Water. In that movie, right, the resource that the humans want to take from Pandora is this like whale goo that they say, it halts the aging process. Like you stop aging if you use it. Now, my advice is, if you're looking for a goo that will halt the aging process, it's called sunscreen, and you should wear that. But anyway, it's possible that civilizations just don't colonize the stars. And now, finally, this is the one I think a lot of people are probably waiting for, the solution that the aliens are already here, right? like what if, like, you're probably sitting here like, damn, what are you going on about the dark forest and all this stuff? Like, you're missing the forest for the trees. We got UFOs that are zipping around all over the place. You got that alien spaceship that crashed at Roswell. So here's the thing, though. Astronomers like myself image the entire sky every clear night, and generally we don't run into these UFOs. Any astronomer will tell you lay people are not very good at identifying flying objects. It is a fairly routine phenomenon for observatories to receive UFO reports called in, and usually they are normal astronomical objects. I think we all probably lived through the drone mania about 6 months ago. I was interviewed by the news for this. I told them the truth. I told them that I had read that there were these drones that were flying over 50, 100 feet, the size of a Buick, and I went up to the park near my house, Eagle Rock Reservation, which is 600 feet above Montclair, New Jersey, and I ran into a whole bunch of people who were looking for drones. There was a news crew there. There were a couple of people on a date. They had a frozen yogurt they were eating in their car that was adorable, but everybody was looking up. And I thought that was really funny. I was like, well, if these things are 100 feet up or 50 feet up and buzzing over houses, we should be looking across over the cliff, and they should be under us. And I didn't see anything like that. And I went out night after night. I never saw anything that didn't look like an ordinary airplane. But some of you might be thinking, well, didn't the government already confirm that they're aliens? Whatever happened with that? And so this is true, but you do sort of have to change the meaning of the word government, confirm, and alien. So here's what actually happened. In 2017, the New York Times published an article about a series of UAP videos that had leaked from the U.S. Navy. And journalists and laypeople, generally not trained to identify objects in classified military infrared cameras, had sort of a field day with this. But it turns out that the most interesting story, but far from the most interesting video, came from the Nimitz incident. So USS Nimitz is an aircraft carrier. They got these weird radar returns of like strange objects, and they sent up a couple of fighter pilots to go and intercept them. And so you may have heard about this Tic Tac object that they encountered. So that object, whatever it was, is probably not the thing in this video. This is the video that was taken not by the fighter pilots that encountered the Tic Tac, but by the other fighter pilots they sent up later that had a camera. Now, the pilot who took this video probably thought he was looking at an airplane. He probably thought he was looking at a foreign military command plane, like an AWACS, and that actually might be what it is. So if you go on YouTube, Mick West is a really good researcher who actually has some fairly convincing explanations for these videos. He does UFO investigations basically as a hobby, and he'll like look at whatever videos you send to him. He has a bunch of other people who do this with him, and he has made a fairly compelling case that that's an airplane. The expert analysis from the military and the government have basically concluded the same thing, that these are videos of airplanes, balloons, and airborne trash. Also worth noting, the actual incident, like the actual story that was told by the pilots who encountered the Tic Tac, is very similar to the 1948 UFO incident called the Gorman dogfight. So this is an illustration of the Gorman dogfight. So Gorman was a U.S. Air Force pilot who was sent up to investigate a UFO, and he described this thing sort of flying circles around him and, doing aerial acrobatics that defied the laws of physics. But the guys who were in the control tower watching this said it was standing still and he was flying around it, which suggests that this is an optical illusion. And that object was probably a balloon. It seems likely that the Nimitz incident was something similar, where the best explanation is that it was an optical illusion created by what we call the motion parallax effect. Another thing I just want to highlight about the UFO phenomenon is that a lot of the mystery surrounding UFOs seems more like a symptom of secrecy than a symptom of aliens. So, like, you may not know this, but the Air Force actually already admitted that Roswell was a hoax, or there was a cover-up. In 1997, they came out with a report explaining that it's true, they were lying about Roswell the whole time for 50 years, and what actually crashed in Roswell was not a weather balloon, but a spy balloon, and that's why there was a cover-up. Now, maybe they're lying still. Maybe this is a new cover-up, but I think Occam's razor leads me to conclude that they're probably telling the truth. David Grush in 2023 was a former government employee. He testified before Congress about some really incredible stuff, but unfortunately, he said it's everything that was really compelling evidence was classified, and there's since been no unclassified proof of any of it. And it's worth noting that, it's possible that part of this is just a rumor mill. Like, suppose you work for some contractor, you're a material scientist, and like some guy brings in a sample of metal and says, hey, this came off of a crash, we need you to figure out what it's made of. you might not know whether it came from an alien spaceship or a Russian plane. Now, according to the CIA, the U-2 spy plane accounted for at least 50% of UFO sightings during the 1950s. So this is a picture of a UFO taken from another UFO. This is the Chinese spy balloon that came through our country in February of 2023. Yeah, that was 2023. And yeah, one of the most classified aircraft in history, and that's a selfie from the inside of it. Oh, what happened? Okay, so you might be thinking, like, wait, Dan, you don't think there's anything to these UFOs, right? Like, well, I'm sorry. Like, I'm a 90s kid. I love my X-Files. I want to believe. But we have spent a lot of time and money as a society looking into UFOs. And so far, I don't think we've found anything that is nearly as exciting as the WOW signal. I try my best in this talk to present all of these solutions fairly and give them their best hearing. But the paucity of evidence around UFOs makes it difficult for me to take this one seriously. Don't let my cynicism spoil it for you, though. If you believe that they are already here, then I want you to vote for that. The truth is out there. Okay, so now we're going to do the bracket. So, let's see. How do we... I think we got to click start. So, yeah, we'll start in the battle between the stay-at-home civilizations and the Great Filter. So we're going to do this by a...
So for this, how we're going to do it is people online, I'm assuming there's numbers up there that I can't see because I don't have my distance glasses. You're going to type either the number or what the title is because, again, can't read, small print, no distance glasses. People here, you're going to raise your hand and laugh and cheer as loud as possible for the one you believe is the correct one. So
I would describe it as the more compelling one.
The winner out of the two.
Out of the two, yeah. So our first matchup is between stay-at-home civilizations. This is the idea that interstellar travel or interstellar civilization doesn't exist, or the Great Filter.
Right, so for everyone wants to just be a homebody and stay at home. So convincing.
Spooky Great Filter.
We're in a colander and can't get past it.
That sounded pretty even. I actually felt like stay-at-home civilization was probably one on enthusiasm. Do we want to check?
So first one, stay-at-home civilization, everyone stays home. Second one, which is
Great Filter.
Get past the filter. I
All
don't
right.
know. I think second one won it there.
Everybody believes in the Great Filter.
I
Okay.
told you needed to be loud.
Okay, the next matchup is between We Are Early and We Don't Know How or Where to Look.
All right. First option, we are early. Second option, we have no idea what we're looking for.
That was hands down.
Yeah, that was the second one, hands down.
All right, third matchup. They're already here versus rare civilization is rare. So basically the exact opposites. The one where there's aliens already on this planet versus the one where there's no aliens at all. Or the
All right. So the first one, they're already here walking among us. Or the second one, they haven't made it quite to organized society yet.
they never figured out fire.
I think the first one won on
Okay.
that one.
Yeah. I feel like it's only fair given how biased I am against it. Okay.
Right. So the first one.
That's a nice one. This is Dark Forest versus Rare Earth. So, spooky Dark Forest, everyone is hostile.
Everyone wants to eat you. The second one.
Rare Earth.
Earth-like planets are very hard to find.
It feels like a tie.
Okay, let's try that again. Everyone is out to get you and burn you down for resources. Second one. Earth is a very hard thing to find.
I think it's rare earth.
Yeah.
All right. We have to do this only 3 more times. So, great filter versus we don't know how or where to look. So, spooky great filter.
Great filter. Everyone's stuck behind the colander. Or the second one, we have no idea what we're looking for.
That was a
pretty
clear victory. All right, now this is I'm really excited for the possibility that they're already here is making it this far. So this is
they're already here walking among us.
Earth is rare.
Earth-like planets are hard to find. If you're booing, you just add to the volume. I'm not actually listening to what you're saying. So let's try that again. They're already here.
Earth is rare. I think I feel like
the first one won.
I have to give it to they're already here. This is incredible. I'm so excited that the final matchup is between we don't know how or where to look and they're already here. 'Cause actually, if you think about it, if they're already here, we definitely don't know how or where to look. So yeah.
I feel like one's confirming the other here.
Yeah.
So we have no idea what we're looking for, how to find it. Or they're here among us.
I think that's a winner. I think we don't know how or where to look. Takes it all the way. But yeah, okay, so we have chosen our winner. A few more things to close us out.
Was that the first time that one won? Or?
No, that was not the first time that one won. That is actually the first. It would have been the first time anyone other than that one won. But that is the farthest that I've ever seen. They're already here. Go.
I think you need to put a little slide together, and we'll post it to the Facebook about statistics of where all the answers line up each time.
I wish I had preserved more data other than just knowing we don't know how or where to look always wins.
This is the important thing, people. The difference between messing around and science is writing things down.
Yeah. Okay, so anyway, before I introduce all these wonderful books and lectures, I just want to tell you the story of how I actually came up with the idea for this talk. So I went to one of these lectures, the last one, Why We Might Be Alone by Professor Dave Kipping at Columbia University. And I asked him in the Q&A what he thought about the grabbing aliens model. And he said, well, I mean, it's a model that's internally consistent, but you can go out and buy a book that's like 101 solutions to the Fermi paradox. So I went home and I went on Amazon and I typed in 101 solutions to the Fermi paradox and I found the book. It's not 101, it's 75. It's called If the Universe is Teeming with Aliens, Where Is Everybody by Stephen Webb. So the first edition had 50 solutions. The second edition he added 25 more. That book kind of motivated me to see this as a really interesting kind of icebreaker question, and that's where I got the idea for the talk. Another good book on this topic I've read is Aliens, the World's Leading Scientists on the Search for Extraterrestrial Life for Jim Al-Khalili. But I think one of my favorite books on this topic actually might be UFO by Garrett M. Graff. The only complaint I have, and I'll bracket this here partly because it might help sell you on the book, is that the title and subtitle are kind of wrong. So the title is UFO, but it's really not just about UFOs. And the subtitle is the inside story of the U.S. government's search for alien life here and out there. And actually most of the stuff in the book is not the actions of the U.S. government. They're actions of individual astronomers and universities and or interest groups, UFO groups and stuff. But it does tell a parallel story of both the search for extraterrestrial intelligence that astronomers are doing and the UFO movement and the UFO subculture and government responses to that. It's a really good book. I really enjoyed it. But yeah, so I'll leave you with this quote from Arthur C. Clarke. 2 possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying.
All right. Thank you, Dan, for another great talk. So, we are going to be doing a question and answer session. But before that, I saw a couple of you sneak in uh, during the presentation. So, just reiterating the safety briefing for those who are here. If you need to use the restroom, that is the porta potty in back to my left, your right. Behind me, also to my left, there is a museum and gift shop area. Feel free to check that out. We have a little meteorite display and whatnot. In addition, it looks like we are actually clearing up, so we should maybe actually get to see some things. Uh, and it looks like we have a couple of the observatories open and volunteers manning those. So do feel free to go up to those observers manning those and ask questions and see what's through the telescope. So, also, when we go to leave, we are using our headlights. We do not want to get run over. We want to keep our streak of no one getting run over alive and well. And that being said, any flashlights we might have, do keep those pointed towards the ground. We don't need to accidentally blind people if we don't need to. So, how question and answer session is going to work. For those of you here, you're going to raise your hand and kind of wave it about. I've been staring at a screen, so I'm slightly night blind. That's why the motion's important. I'm kind of like the T-Rex in Jurassic Park. If you stop moving, you cease to exist.
I really appreciate that you described that as the T-Rex in Jurassic Park, because actually that is just from Jurassic Park. There's no reason to think T-Rex's vision was actually motion-based. They made that up for the movie.
Yeah. Although, that being said, I have seen chickens completely lose the plot if something stays very still. And let's face it, chickens will eat anything and anyone if given the chance. So, like I said, people here raising our hands, waving it about like we just don't care. Online people, you just get the easy job of typing in chat. We're going to start this off with our first online question. And that was... Sorry, I lost it. Doesn't it seem mathematically improbable that the Earth is rare, just like it's mathematically improbable that we are some of the only sentient life forms?
So that's an interesting comment. I think there's a so I guess we have to think about what we mean by mathematically improbable, because and probability statistics is a field of mathematics that is somewhat philosophical. I think the dominant approach to statistics in the modern world is what's called Bayesian statistics, or if you have to be persnickety about pronunciation, Bayesian statistics. And in Bayesian statistics, what you're basically doing is updating your understanding of the world based on data as it comes in. We have a sample size of 1 regarding how common life is in the universe. So it's difficult for us to make like statistical predictions about how common life might be. I think the rare earth question is more addressable. Like, we have more data about how common planets like Earth are, at least from the perspective of we know how common planets are in the universe. We know how common rocky planets are to some degree based on what we get from exoplanet astronomy. But in terms of like saying, like, if we knew for a fact that a star had a planet that was the exact same size as Earth, would we be able to tell easily that this was more like Earth, more like Mars, or more like Venus? We're not there yet. We're getting there. We're getting closer. But the things that make up the rare Earth hypothesis, the ideas of like, you've got this big giant moon, you've got a thick atmosphere, you have an active magnetic field that's protecting the planet from cosmic rays and from solar radiation. Like, those I don't think we can make meaningful statistical comments about, at least not as yet.
I think they were more just thinking about there are so many galaxies, so many stars. It would be unreasonable to think that we are completely unique.
Yeah, I think, well, my comment was really about saying, like, questioning that premise, because I think we don't, necessarily know how. So the example that Stephen Webb uses in his book, which I found pretty compelling, was
Also, remember, other people have questions.
yeah, we'll get there. We'll get there. So Stephen gives the example of the sieve of Eratosthenes, which is the way that you determine which numbers are prime numbers. So you take the way you do it is you start with well, you can't start with 1. Start with 2, which is the first prime number, and you list its multiples. The multiples of 2 must be composite numbers. The multiples of 3 have to be composite numbers. The multiples of 4 have to be composite numbers. So you basically go down this list of all the numbers, and if you never hit any of them when crossing off the multiples, you know you found a prime. Basically, his suggestion is that it's possible that if we applied this logic to life, it might turn out that, yes, the universe is very vast. It has a lot of space for life to exist, but there's also a lot of reasons why it doesn't. Okay, next question.
Right. Question out here. Ooh. We got one out here.
I missed the beginning, and I apologize. I assume you went into the Drake equation in the beginning?
I didn't. I avoid talking about the Drake equation in this talk because the Drake equation can produce the result that every rock in the universe has a civilization underneath it, or the result that there's less than one, depending on what assumptions you make and how you run the numbers.
But it's a multiplication of probabilities, basically. But what I wondered is, does any of your sources talk about the fact, because you seem to, especially with the bracket, suggest there is more of a bottleneck issue with not finding any civilizations. However, it could be systematic in the sense that just the amount of probabilities one is multiplying together in order to get a civilization successfully through is so large that it itself is the limiting factor and not any of the bottlenecks, individual bottlenecks.
Well, I think each one of the probabilities is basically a bottleneck, right? Is like if it turns out that basically so just in case anyone is not familiar or is a little bit lost on what the Drake equation is basically like this was similar to the Fermi paradox itself. This was something that came up as like a lunch conversation with some astronomers. So Frank Drake basically, as a food for thought at this convention on the study of extraterrestrial life, suggested like, well, what you could do is you could take the rate of star formation, multiply it by the fraction of stars that have planets, multiply it by the number of planets the average star has, the fraction that develop life, the fraction that develop intelligence, and so on and so forth, and then you bang these all out, and then you get a number that is just how many civilizations there are in the galaxy. And depending on what assumptions you make, you'll get different numbers. So if it turns out that the emergence of life is a great filter, that like life just doesn't emerge that frequently, then the fraction of planets with life would be the thing that clobbers the whole equation. The Drake equation is really cool. It's a amazing thing that it has remained with us for about 50 years, even though it doesn't really make concrete predictions and is technically is arguably not scientific. But basically, the task of SETI is to fill in those fractions, right? Like the more we learn about the universe, the more we can do to nail down what those fractions are. But also, once we find an extraterrestrial civilization, that kind of it's like now we're already at the end. I guess we can go back and change our assumptions, but we already won. We already finished.
All right. So our next online question: wouldn't the current existence of AI as it is be an early implementation of silicon-based life?
Oh, that's such a cool question. It's not really. It's so like I get the sort of what the thrust of that is that like
Someone's
because
been watching iRobot.
the computing the substrate the computing substrate of AI is silicon based chips, but that's not really what people mean when they say silicon based life. When people say silicon based life, what they're saying is the idea that like you could have a biological entity like ourselves, at least in the sense that it consumes energy from its environment, and then like reproduces itself and excretes waste. That the things that our bodies use carbon for, it would use silicon. And the reason people believe this is that silicon is pretty similar to carbon in the kind of bonds that it can form. But the problem is that those silicon bonds are higher energy than carbon. It's possible that there might be some like hybrid kind of like life. There are some, creatures on Earth that have like silicon in their bodies, like in the cell wall and things. So like, is that silicon-based life? I think that's not what people really mean. Like, but in the same vein, so yeah, I don't think that the emergence of AI is a sign of a future silicon-based life. I'm not sure that I even believe that AI is intelligent. It might be very powerful. I don't think it's going to replace us. It might replace some of us, but I don't think it's going to replace our civilization.
Things I want AI to do: find the most efficient path to vacuum my floor and do it by itself without me telling it to. Things I don't want AI to do: make art for me. I want to make the art.
Yeah.
Anyhow, any questions out here? We don't even have the crickets. It's so cold.
Yeah, I think for those watching online, it's really cold here. That's why people seem a little like.
Yeah, the wind was whipping earlier, and it
I'm
kind of
excited to go
took
inside.
all the warmth away. But it did bring some lovely clear skies, so I can't be that mad. All right, so our next online question. Does backlighting the structures in your eye harm your eye? Also, are there ways a normal person can see their eye structures like that safely?
I have no bloody idea, but I'm probably like I used to use a flashlight or something. I don't think it's harmful for your eye. I think you have to be really obsessed with Mars to use it to see the structures of your eye.
I think that's perhaps a question best asked of an eye doctor.
Yeah.
Just because they would best know what is and is not harmful for viewing these structures in your eye, and chances are they have a tool for that.
They do. It costs $50.
So
Good news, my eyes are healthy.
So next time you go to the eye doctor, perhaps ask them. I'm sure they'd love to show you that. And if not, find a doctor who would. Like I said, anyone out here, if you have a question, do raise your hands. Online people do get those questions in. And I say this now just because by the time you hear this, we're already like a couple minutes into the future, since that's how stream delay works. Right, so our next one is less of a question and more a comment. So, if your significant other has a temper, could you safely say that they are more reactive than oxygen? Or at least as safely as you could tell them they're being emotional.
Yeah, you could say that. I feel like chemists must have really great ways to mock one another.
Yeah, I wrote in chat for that one. That is not a safe activity. I would not advise, especially if they are fond of chemistry, they probably know what you mean. So yeah, don't do that. All right, any questions? Bueller?
Not even from the dogs.
Okay, the question was, do we think aliens have pets?
I hope so, because if they come here, like that might, if the dark forest hypothesis is true, that's our best bet.
That they want to take us as pets?
Yeah, I'm down for that.
Like they're like elephants and think humans are cute?
Yeah, I'm ready for that. Like, I don't need a day job.
True, there are some points where you start thinking, man, our pets have it made. They sit there, they just provide love and are adorable. They get fed, they get bathed, don't have to work a day in their life.
And yet they still sigh. You gotta wonder, like, what are they so stressed about?
All right. So that looks like the end of the questions that we have. So I want to thank everyone once again for joining us. For everyone here, do have fun viewing the sky. Like I said, it has cleared up wonderfully. For those of you online, thank you for joining us. Do hit those like, follow, subscribe buttons, depending on which streaming platform you're using. Do check us out on our website, uacnj.org. And like I said, we are a nonprofit, so anything you guys do to support us, whether it be those free actions or whether you're feeling generous and want to support monetarily, there are ways on our website too, and it does help us greatly keep paying the bills to be able to offer this overall free content to everyone. And with that, clear skies and good seeing.
Good night, everybody.